Welcome to Mathematics Lecture series. Our topic is limits of function by theorems or by formula. This is lecture number 13 in Applied Calculus series. We have to prove limit x tends to infinity 1 plus 1 over x whole power x is equal to. By using binomial theorem, we open that 1 plus 1 over x, which becomes 1 plus x 1 over x, that term, plus here x minus 1 power x minus 1 over 2 factorial 1 over x whole square, so we will have 1 over x square plus x minus 1 x minus 2 3 factorial 1 over x whole cube 1 over x and so on. So x will cancel with x, we will have 1 plus 1, and we check the common x, so it becomes 1 minus 1 over x. So x we have taken the common, so it becomes x square. So 2 factorial, here we have x square, so this will x square cancel with x square. Similarly we done for that term, and we will have x, here is x is a common, so 1 minus 1 over x, here x is a common, it becomes x cube 1 minus 2 over x, and this x cube will cancel with x cube. So we will have 1 plus 1 1 minus 1 over, apply the limit. We apply the limit, so 1 over x this term, 1 over x this term, 2 over x goes to 0, because x tends to infinity, 1 over x 1 or 2 over x goes to 0. So we will have 1 plus 1, here from we have 1 over 2 factorial, and from that term we have 1 over 3 factorial plus x, and so on. You know that limit x tends to infinity, c over x goes to 0. We apply it in that 1 over x 1 over 2 over x goes to 0. What about this 1 plus 1 1 over 2 factorial? It is a series of e, because the sum of n on finite series approximately equal to 2.7182. The sum always lies between 2 and 3 and denoted by a. So we can say that limit x tends to infinity 1 plus 1 over x, and 1 over reciprocal of if 1 over of x and the power of that, so we will have e. So by using this we will solve the limits. So corollary in above limit b, if we put y is equal to 1 over x, then what about y will approaches to 0, as x approaches to infinity and y approaches to 0, approaches if x will y will approaches to 0 as x approaches. So this limit x tends to 1 plus 1 over x, we make the transformation 1 over x is equal to y, so limit y tends to 0 1 over x also is equal to e. You must know that 1 minus 1 plus 1 over the alternative sign, so it becomes e power minus 1 is 1 over e. Now solve these examples. Limit x tends to infinity 1 minus 1 over x whole power x, 1 plus 1 m x 1 plus m over x. So 1 minus 1 over x whole power x, limit s tends to here 1 plus, we made according the formula, because we will have 1 plus 1 over x whole power x is equal to, so 1 plus 1 minus 1 over x. So here limit x tends to 1 plus, we must have the reciprocal of that here, so we multiply here minus x and minus whole power minus 1, minus into minus plus, so we multiply and minus with minus. So what about this? This is by using the formula 1 plus 1 over x, here we have the reciprocal of that minus, so it is e, and whole power minus 1, so 1 over e. Limit x tends to infinity 1 plus 1 over x mx, so limit x tends to infinity 1 plus 1 over x whole power, we can write it that in this way. What about this? This is a e, by using the formula limit x tends to infinity 1 plus 1 over x whole power x is equal to e power m. So we will have answer e power m. On limit x tends to 1 plus m over x. So we multiply and divide with m, multiply and divide in power m. So what about this 1 plus m reciprocal we have? So this is e, and we have power m, so e power m. This is now we also prove this formula and prove that limit s tends to infinity a power x minus 1 over x, it is equal to log a ln a. We replace x0 in the above function. If we apply the limit x0, so a power 0 1 minus 1 0, we will have 0 upon 0 form, which is in a determinant expression. To find the required proceed as under a power x minus 1, we write it is equal to y. Then what about the a power x 1 plus y? Taking log on each side, we will get moreover as x tends to 0, y also tends to 0. Here x tends to 0, not infinity. So a power x minus 1 over x, here if x tends to 0, by this expression x tends to 0, so y tends to 0. We apply x tends to 0, so we will have y tends to 0. Ax minus 1 is equal to y, and what is value of x? By using here both sides log, we will have x is equal to ln 1 plus y over ln a. So ln a, we can write it in numerator ln a 1 plus ln 1 plus y over y. We can write it. This is same form. What about this limit y tends to 0 ln 1 over y ln 1 plus y? So here limit y tends to 0 ln a, ln we can by the using of property of logarithmetic, logarithm 1 over y becomes the power of that 1 plus y over 1 over y. Ln a is a constant, so we can apply the limit outside, inside. Limit y tends to 0 1 over ln 1 plus y 1 over y. Ln a, and what about this 1 plus y over y? Limit y tends to 0, it is becomes e by the formula limit x tends to 0 1 plus 1 over x is equal to, so it becomes 0. Limit y tends to 0 ln 1 plus y 1 over y. So 1 plus y over y 1 over, if we apply the limit, so we will have e. So ln a over ln e, it is ln e is also equal to 1, so you will have just ln a. So limit x tends to 0 a power x minus 1 over x ln a. Here is a 0, so you must rewrite here 0 in your copies. Note limit y tends to 0 1 plus y is equal to e, ln e is 1. Evaluate the following limit by using the formula. Limit x tends to 0 25x minus 16 over x minus 1. So limit x tends to 0 25 power x minus 1 16 power x minus 1. Limit x tends to 0 25 power x minus, we multiply and divide with x here, 16 power x minus 1. So limit x tends to 0 25 over x here x. What about this? By using the formula of the previous limit 25 power x, it becomes log 25. And what about this limit x tends to 0 x 16x minus, it becomes log 16. By the previous slide you can see we will have the formula ln a power x minus 1 over x is equal to ln a. So here ln 25, and here we also, by using the formula ln 16. So 25, we can say this is 5 square and 16 is 4 square. So by using log property, you can write the coefficient this power 2 log 5, 2 log 4. So 2 will cancel, 2 will have log 5 over 4. So limit s tend 25 power x minus 116 power minus log 5 over log. Similarly, limit x tends to 0, 25 minus 16 power x over x. How can we solve it? Limit x tends to, we add and subtract minus 1 plus 1. So 25 minus 1 here minus 16x over x. So if we separate, so 25 power s minus 1 over s minus 16 power x. So we apply the limit by linear principle. We will limit x tends to 0, 25 over x minus 1, limit x tends to 16x minus. What about by the formula? Limit x tends to 0 a power x minus 1 over s. So it becomes log 25. What about this? Becomes log 16. By logarithmetic property, you can divide as log 25 over x. 25 over x, we can write 5 over 5, 5 over 4 whole square. So by log, you can write the coefficient 2 log 5 over. This is the lost answer. So now another problem, limit x tends to 0, 1 plus 3 x 1 over x. Limit x tends to 0, 1 plus 3x. So we multiply and divide with 3. So 3 divide 3 multiply. So by the formula, this is e and e power 3. Last answer is e power 3. Kindly subscribe the channel, like the video. Thank you.